Okay, guys, we're going to do 4.4 actually today. We're going to skip 4.3 for now. We're going to jump right into 4.4. This is the quadratic formula. Okay, now the quadratic formula, you learned in Foundations 20 as well. Basically what it is, it's a formula now that you can use to solve any quadratic that you're given that may not be factorable to find the x-intercepts, okay? So this will find any x-intercept. And you need the formula, you need to work with a quadratic in standard solution, okay? So you need A, B, and C. And then all you do is you just plug everything into here, and then you solve for x. And this will give you two equations because you got the positive and the negative here. Remember, whenever you square something, so if I was to take the square root of 4, we say that's 2. But, because we know that 2 squared equals 4. Or you could say negative 2 squared equals 4. So there's always two possibilities there. So that's where this guy comes in. And you need to remember that, okay? That tends to be the one spot that kind of trips people up. It's this plus or minus sign. And you just need to remember that. I could sit here and explain things all day, or I could just go ahead and do a bunch of examples and show you guys how it's done. So the first one here, here's my equation. It's set to 0, so I know I'm solving for the x-intercepts. I could try to factor it, but for this one here, I'm just going to go ahead and use the quadratic equation. So here's my a value, that's 1, b, and c. So I know that a equals negative b. So I'll write the first one out with all my signs, just so you can see everything. Okay. You know, if I work this out, now did I leave myself enough room here? Okay, so this is going to be positive 6 plus or minus the square root of 36 times 8. Over 2. Now at this point here, we haven't reviewed radicals, so I don't expect you to simplify this just yet. You can leave it as that. Okay? So this question is done. So your two answers would be 6 plus root 8 over 2, or 6 minus root 8 over 2. And those are your two x-intercepts. Now if you notice, like you would never be able to factor this, so this one's unfactorable, right? So the next one here, I'll try this guy again. This time I'm not going to go through and do all my sign work for you guys, okay? Now remember, whenever you're squaring a negative number on your calculator, it's going to give it to you as a negative. Just remember that you need to go through and figure that out, okay? So remember, whenever you square a negative, it should be positive. Your calculator just automatically makes it a negative. So this is just going to be 5 plus or minus. Now 25, take away 28. Negative 3 over 2. Now, can you take the square root of a negative number? No. So what actually happens here is there are no x-intercepts. Whenever you have a negative under the root symbol, you cannot go on. It's done. And what that looks like, that means you have no x-intercepts. So you have something that looks something like that. Okay? Doesn't touch the x-axis at all. So the quadratic equation itself is pretty straightforward. Everything that you're working with is review at this point. You're just adding, subtracting. You're taking the square roots of numbers. Nothing you haven't done before. You just have to watch your signs. Like you got two negatives, make sure they become a positive there. And remember, whenever you square a negative number, it becomes positive. And then, of course, remember to split it up into two equations. So now let's make it a little bit harder here, because that's what we do in pre-calc 20. So this guy here, I'm going to work all this out. Okay? So I'll do the FOIL of this guy first. So that becomes x squared minus 1. That's a difference of squares there, right? Now, if I work that out again, it becomes 2x equals 3x squared minus 3. Bring the 2x over. Oh, no, minus 1 minus 3. Like so. Now I have a quadratic that I can use the quadratic formula for. So it's going to look like this. Okay. Oh, -3 here. Remember, watch your signs. That's going to come 2 plus or minus 4 plus 36, which is 40, which is over 6. So you're going to get two answers of 2 plus 40 over 6, or 2 minus 40 over 6. Now, if you want to be so bold, I'll go down here and I'll do it a little bit more. If you stop here for right now, this is fine. We haven't reviewed rational number or radicals at all. But if you wanted, you would know that root 40 is actually, remember, to simplify these, you look for factors you know the square root of. We know the square root of 4. It's 2. So this is actually 2 root 10. So you could write it like this. And that's fine as well. Or if you really want to get ambitious, you can simplify. I can take a 2 out of all 3 numbers. So then it becomes 1 plus or minus root 10 over 3. And there's my x-intercepts there. Okay? So for right now, this is totally fine here. But if you want to go a step further and earn a couple bonus marks, that's what you have. This will be expected of you at the end. Okay? Once we review how to work with radicals, it will be expected that you can do this for any question. All right, now last one, or this one here. I'm going to bring the 5x over. I make everything equal to 0. All right, now I'm ready to work with the quadratic equation. So these are fractions, so it's not going to be pretty. 5x plus or minus -5, 6 squared minus 4 times 2/3 times 1 all over 2 times 2/3. Okay? Make sure you pause as we go along here and you follow along and you understand everything. This can be a little tricky with the fractions, but I have total faith in you guys. All right, so make sure I don't run out of room here. I'll continue this in blue just so we don't get confused with anything. So 5 over 6 plus or minus. Now 5 over 6 squared becomes 25 over 36 minus 8 over 3 all over 4/3. 2 times 2/3 is 4/3. Now if I continue along, I need a common factor here. So common factor, or common denominator, sorry, between 36 and 3 is actually 36. So I multiply this thing, everything here by 12. Okay, so multiply everything here by 12. 12 times 8 is 96. Now if you look, 25 minus 96 is actually negative 71 over 36. Now, can I take a negative value of something? No. I'm sorry, can I take a negative, can I take the square root of a negative number? No. So once again, it does not exist. All right, so that's the quadratic equation. We're going to spend some time practicing this. We're going over this stuff, so don't worry if you see fractions right now. Panic, it's okay. Decimals are fine. You can work decimals out. You'll get the right answer. All right, let's move on to some word problems now. All right, so rectangular garden, like so, has dimensions 5 by 7. Okay? Both dimensions are increased, 7 up here. Both dimensions are increased by the same length. The area of the garden increases by 45 meters squared. Determine the dimensions. Oh, that should say increases to 45 meters squared. Determine the dimensions of the larger garden now. So what I've done, what that means is I've had this garden. Now what I've done is I've truded it out by X amount here. I've truded it out by X amount here to increase my garden by so much. And now my new area is actually 45 meters squared. So what I need to do is I need to determine this value X. All right. Now, with these quadratic word problems, because it doesn't say anything about a maximum or minimum value, and I'm trying to solve for an actual value of something besides the vertex, I'm going to use the quadratic equation. Okay. So unless it says max or min in the word problem, it's quadratic equation. So I know that area equals length times width. Now I know my area of this, my length here is 7 meters plus the x that I've added. So my length is actually 7 plus x. And my width is 5 meters plus the amount that I came out by, which is x again. So my width is 5 plus x. And I know my total area for this guy is going to be 45 meters. So now I have an equation I've set up. 45 equals 7 plus x times 5 plus x. So now I need to solve for x. So first thing I'm going to do is I'm going to do all my FOIL here, do all my distribution properties. So I'm going to rewrite it now. It's 35 plus 12x plus x squared. Now I'm going to bring this over, make it all equal to 0, so I can use my quadratic equation. Okay, now I have my C, B, and A values. X equals negative B plus or minus B squared times 4 times A times C all over 2 times A, right? Now if I work this all out, it's going to become 144 plus 42. If I take the square root of 184, that's negative 12 plus or minus 13.6, all divided by 2. So there's two possibilities here. If I split this out, because I have the plus or minus here, it could be negative 12 plus 13.6 over 2, or it's going to be negative 12 minus 13.6 over 2. So now when I look at these, if I add these together, if I add these ones together, I can see I'm going to have a negative number in the end. And what I'm looking for is a dimension. So can I have a negative dimension? No. So this one is no good. If I look at this guy here, I can add these together. That's going to give me 1.6 divided by 2, 0.8 meters. So I only added 80 centimeters to both sides, which kind of makes sense if you look at your original graph or your original garden. It was already 5 times 7, 35 meters squared. Okay? So that's how those work there. Okay? Let's do one more. Okay, the surface area of a cone, or sorry, of a cylinder is 250 centimeters squared. The height of the cylinder is 7 centimeters. What's the radius of the cylinder to the nearest hundredth of a centimeter? All right, so to work this one out, you need to know the surface area of a cylinder. Now, I want to test if I ever give you anything like this, I will give you the area formulas that you need. All right, so area of a cylinder is 2 pi RH plus 2 pi r squared. Okay. So now we know we've been given the area, and we've been given the height. It's 7 centimeters. And we know what pi is. So the only thing we need to solve for is r. And if you look here, because of the r squared, this is actually a quadratic. So we can use the quadratic formula. So if we plug in all the numbers that we have, two times pi times 7 times r plus 2 pi r squared. So this is going to be 250 So then I'll bring the 250 over. I'm just going to rearrange everything. Minus 250. Now if you want, most of your calculators should have a pi button for you to use as well. So you can actually go through and you don't have to put 3.14 in if you don't want to, but you can. It's up to you what you're more comfortable with. I think for now what we'll do is we'll just figure out what these values are. Okay. And I'm just using 3.14 as pi. So this becomes 0.28 r squared plus okay, so there are my values. So now I'm going to pause it. I want you guys to try to set this up and see if you can solve it. All right, so I did the work. Follow through and see what you can understand. Now, if you notice, I didn't do the minus 1 over here as well because it would have given me a negative number, which I can't have a negative dimension. So I got 3.72 centimeters. So go through this. I did all of this step here all at once. I went 43.96 squared minus, hit the brackets, 4 times 6.28 times negative 250, hit enter. Then I took the square root of it right away, and then I was done with it, and then I could just keep working, okay? Now, these questions are not made to be simple. No, they're supposed to take a little while. Welcome to grade 11 math. Word problems now take 10 to 12 minutes a piece, all right? That's just something you'll have to get used to. I'll put up the assignment, and good luck, guys.